Hello, in this video, I'm going to explain what the hell I'm building for a hedge fund client. So the essence of the problem is that the trading system doesn't expose links between buy and sell trades, which you need in order to do consolidated cross-system profit and loss reporting firm-wide. So the problem is, there's a lot of complexity to this problem. One is that there can be many-to-many trades. So you have a buy trade for $60, another buy trade for $40, a sell trade for $70, and another sell trade for $30. And they all co-occur within the same kind of sub-second for the same currency. Those should be matched as kind of a grouping of trades. And then you calculate the profit and loss across that grouping of trades. So that's one complexity. And then another complexity is like large order sweeps. So you can have, for the same account, the same currency pair, the same option expiry date, like a whole ton of orders that happen in the same second, and they all need to be matched and like farmed out accordingly. So this is really hard to do programmatically. So I got to a point in my code where I was able to match. So I look for a partition group. So that when I say partition group, what I mean is same currency, same option expiry date, same account, and succession of trades occurring. That's a partition group. So I was able to get it to a point where I could do the matches. If there's multiple matches within the same partition group that occur in immediate succession, I could find them. What I wasn't able to account for in my code was if there was a matching, and then there was a gap, and then there was another matching. So this prompt here was basically to account for gaps that can occur in the matching. And it's very like specific to the code. You can't prompt ChatGPT by saying remove the gaps. You have to prompt it in really precise ways of like how to edit your function. So I asked it, edit this Python function so that when it makes it to the final iteration of the while loop, it removes the first row from the partition group and reruns the while loop with this new reduced data frame. And it's kind of hard to articulate in words like what you want the code to do. So generally I use it for like getting direction on what to do and then figure out why it's wrong and then fix it. So what ChatGPT then produced was, I'll explain the difference, I guess, between my code in the prompt versus what came out at the end. So in my original code, I had a for loop, a while loop, and then a for loop. What ChatGPT did is it inserted this while I is less than length of partition group condition. Okay, so next thing I did is write this into Snowflake and then come to Tableau and look at the data that it produced. So just to explain the model a little bit, this is a view built off of my Python trade matching table. This is just like the P&L benchmarks that come from the trading system, aggregated up to a client and month level, the common links between the two. Okay, so with this, we can then start to look at our clients, our months, and then this percent difference here, it's just a formula that finds the percent difference between the P&L in my data and the P&L in the benchmark data. And so then we can visualize that. And what I see right away is like, okay, this client this month, there's a severe gap. Why is that? Let me drill into that. So now I'm going to kick out these fields. I don't care about them anymore. What I actually want to look at is the links level of detail for this month and this client. And the thing that's like going to help me most debug the errors isn't by like slicing up the percent difference. Well, you can't because it's not captured at this granular level. What I actually want to look at is the time elapsed. So this is just a formula that calculates the seconds between the buy and sell trade date times. So if I bring in this, I want to see where's the max time elapsed by link. And boom, I can see right away there's these 3 links where like it's not happening in sub-seconds. It's like 13,000 seconds apart. That's something that's going wrong there. So what is it? Let's drill into those. So then when I look at the buy and sell trades that are being paired in these trade IDs, I'm going to produce a super ugly visualization that is meaningless to probably anyone who has not read the code. But to me, when I saw this visualization, it was instantly like insightful and communicative of like where things were going wrong in the code. So one thing that like immediately stood out is this trade here, 410, is being matched 3 times. And that should never happen. A trade should only ever be matched 1 time. So fatal flaw there. And then the next thing that really spoke to me was, if you look at these 2 partitions here, it starts with 384 up to 401, which is close to 410, like that's probably a match. And then it appends this 601 from like another potential order sweep. And so that's kind of weird. And then it goes and knocks off 384 and starts at 385, goes up to 401, and then it's got the 600 again, but then it adds 603. And so if you think back on the original prompt, it's kind of doing what I told it to do, which is like knock off the first row in the partition and increment it. So the code was doing what I told it to, but it turns out I think I just gave it a stupid prompt. Which is the biggest risk of using English to try and describe like really precise mathematical operations. So what I did then after this was continue to look into this data. So I actually want to see, well, instead of just looking at these 3 links, I want to see everything related to these trades. And so then I could start to investigate like, okay, this looks like a likely match for this 605. It's just 3 trades and they occurred within, let's turn the labels on. They occurred within like under 11 seconds. So that's looking pretty plausible, but like this one's also pretty plausible. It's more trades, but they're still occurring within under 11 seconds. And for now, I'm not going to get into like other things that could go wrong. I checked a million other things like, do the buy and sell sides sum up to 0? And yes, they do in this case. Yeah, and then I wondered like, well, what else happens around these trades? So instead of looking at just these 2 trades, what if I look at the partition key itself? So if I keep partition key 6 and kick out the buy trade ID, then what I see is there's this other buy trade, 632, that's occurring around the same time. And so you want to like figure out, how do I maximize the matches that occur for all of these trades? Yeah, and that's really hard to do. So without going into like an immense amount of detail, let me just show you the right answer. So I fixed the Python code, and I only have buy trade ID in my other data source. So let me just fix this to the trade IDs rather than this other stuff. I could call this out. And then I'm going to replace the data source with the right answer. And what you see here is each buy trade is only matched once. Each sell trade is also only matched once. And like a good way to look at that is just by moving these things around, and you can see, yeah, like there's only, they're only occurring once, all good. But yeah, so everything is getting matched in under 12 seconds, which is sort of like within the acceptable tolerance, and like the maximum set of trades got matched. So this is good. Okay, so how did I actually fix the code? The thing that was going wrong is that in this for loop, I was trying to handle the occurrence of multiple consecutive matches and then I was using this outer while loop to handle the gaps. And that's just a convoluted and stupid way of doing it. So what I did instead is use the inner for loop to just find a match, and then use the while loop to find subsequent matches regardless of whether there's gaps or not. And so one of the big problems with this code here is this I less than or equal to length of the partition group. So what was happening here is two opposing forces were like crashing like a giant wave, because I'm incrementing I at the end of every for loop, but then I'm also removing all of the rows that got matched from the partition group. So I is going up while the partition group is going down. And that just doesn't make any sense at all. So what I did is remove the I plus 1 incrementing thing, and then added a break clause at the end of a match. So this break clause here, it just like drastically simplifies the code. And then I do this thing here where I shrink the partition group down to the stuff that didn't get matched. And then I changed the while loop to be 1 less than or equal to the partition group. So instead of having one thing increasing while the other thing's decreasing, one is just fixed and the partition group is going down as matches are subsequently occurring. So anyway, this is not a lesson in coding. God knows I don't know what I'm doing. This was just to give you an idea of like how ChatGPT using AI and like a data exploration tool like Tableau can take somebody who's like code illiterate to somebody who is like capable in a matter of months. So there you have it. Thanks for watching.